I need my slide. Oh, that's the kind of
I mean,
bit
the
bit of
video
mm-hmm,
also
mm-hmm,
created to desktop
mm,
and do this.
okay, mm-hmm.
And background, it will everything is recorded into here at the same time,
Oh,
so
okay.
don't worry about it.
Thank you.
And then you have this,
Mm-hmm,
right?
mm-hmm.
And meanwhile, we will double check Google Hangout in here.
Mm-hmm.
Yeah, already live. Okay,
Okay.
and we have to do share screen
Mm-hmm. Share the screen.
and share.
Uh-huh.
And now,
Sounds
so
great.
everything is sharing right
Uh-huh.
now. And
Thank
we
you.
have this, and we will have full
Share screen.
screen.
Uh-huh.
And I think, yeah, full screen, and then you can start to navigate with this.
Okay. All right. Sounds good. Thank you.
You're using mic, and make sure
Oh,
there's mic.
oops. Okay. Hello. Okay. All right. Again, thanks for coming this workshop. And this is like, the Friday afternoon. It's very hard to sitting in the desk, but I hope you guys, that get more than just, the playing with your friend in this afternoon. I hope so. Anyway, like, the thank you for like you giving the presentation, the Dr. Chen, and so special like the SPSS, and we all know about like SPSS, and it's kind of the user friendly the things. So we missed in so many things the how important or what kind of advantage in the SPSS. And I just found that the several things, and it's really easy to communicate the colleague with SPSS syntax, and because the many people already know about that, and data management in the SPSS. I will give some the information about the data management in R, but still many applied researchers using the data management in the SPSS. And also the SPSS, when we're learning the statistical analysis in about the 5 or 10 years ago, it feels like SPSS is very expensive. But nowadays, the many university like it offered the SPSS free, especially in the UVA, is free. So we don't have any kind of the constraint about using the SPSS. And also when I'm teaching the analysis of variances, I could see many functions in SPSS and much more functions in SPSS than our program. So still like the SPSS and advantage. So if we have the advanced or intermediate session, the next the workshop, and it will be great. Thank you very much for the Dr. Che. And so uh, and I can save a little more time because he explained very well about like the t-test and the statistical concept. So I want to save some time at the end, and what I want to do that is like we have like some kind of a Q&A session. So whatever you have a question, and we can discuss not only about this workshop, but also any questions and if you have. So I want to save some time, and so this is my slide, data analysis with R, and focusing on data management. And the reason I say that like the data management, because the still many people feels like the R is like the computer programming languages and not easy to use. But once you're familiar with like the simple functions, and it's not very different from like an SPSS or the SAS program. And in the cases like if you have some techniques to dealing with the data set, and you can like replace all stuffs in the statistic with our program. So all stuff means like the things been done in the SPSS or the Stata. So I made like some subtitle like that. And today, like I will give a presentation with these 4 different topics. And one is the data input and output, and data management, and basic statistical functions, and statistical models, which is like the correlation to the t-test. And so like the first 2 sessions is very similar, but I just want to distinguish those things because data input and output is more likely to the data format, and data management is like the kind of task within the R program. So I just separate this session, and then we will explore several statistical function, and then we will jump into the statistical analysis. So what is data input and the output? And I know that some colleague the approach to me getting some the consultation about their data analysis. Most likely they bring data set in the SPSS format, no, the Excel format, and sometimes the SPSS format. And so the Excel spreadsheet is like a most common data format. So I want to discuss this kind of the transitioning, how we can import this Excel file to our program. And then I will introduce another way as well. And so here, example one dot XLSX, this data has been used in the Dr. the Chess presentation, and there is the three different the columns X1 and X2 and X3, and those the data format is so familiar with us, right? And but unfortunately, our program does not read this Excel directory, and R required the specific format, and that is nothing but the CSV format, which is the comma separated value files. But it's not very difficult because in the Excel you can just do the save as .csv. Then you can save Excel files as the .csv file in the same folder. And other question is that only format that we can use? No, no. And you can import the Excel file into the our program directory, but you require that you need some specific packages. So packages is nothing but helping the R program runs for certain specific conditions. And so if you have a packages which is called the XLSX packages, and you can directly import your Excel file as the R data files. And so this is the simple way to import your data set. And how does it look like? Is it very complex? I don't think so. And this is the R syntax. And if you see the R syntax, and here, this the right side is our syntax. I just the copy the windows and then paste in here. So as you can see, the shop button here, shop is for the note taking. So shop and using read.csv. Whenever R start with the shop, and the R will ignoring that rows at that line, and so you can just put in the any note in here. So here, example one, and less than minus sign, which is the left arrow, and here, and read.csv. Read.csv is a function in R. And in the cases the R try to read your data set, and after parentheses, and you can the type the file name. So if you save your Excel file as .csv, and you can just type with the example one.csv with a double quotation mark. And then the R will try to read this data set. But as we've seen in the previous slide, this example one.csv has first row as variable name, right? And so if data set has a variable name in the first row, and you can just assigning that first row as the variable rows. So header equal T is saying that, hey, I have a data set example one.csv, but it has first row as a variable name. So in the cases, read.csv, this command, and it will import that CSV file as data file within the R program. And I assigning the data name as example one in here. And once you the upload this data set in our program, and you can use this data set for with any other function. And now example one, and if you just type example one, that enter, and R will print out your data set with the variable name and columns. And so in this syntax, we don't see it, but like it will have like the print the output in our program. And not only this, like the print out within the R program, but also you can have like the spreadsheet type of the data representation, and with like the view functions, capital letter V I E V function view, and example one, and it will like the print out the spreadsheet type like the data set. And unfortunately, R is case sensitive, and capital letter V I E W is totally different from the small V I E W. So don't complain about that, because there are so many functions, and we have to distinguish. And so this is one way. And other way, if you want to use the packages, and there is two steps. One step is you need to install packages in your the computer. And how to do that? And if your computer is connected to internet, and just like type install.packages, install.packages, double quotation with the package name and XLSX, then computer will install these packages within our program. But unfortunately, installing the packages does not automatically working in R. Whenever you want to use the function within that packages, you need to upload these packages in R program. So that function is a library. So the library XLSX is nothing but, hey, I want to use some functions in these packages. And then you can use like the function. So similar functioning as read.csv is read.xlsx. So the read.xlsx example one.xlsx. This is like the Excel file, and then there are several options, and the header is T is the same as before. But what is this one? In the sheet name equal one, and this is like if you have Excel file, you have multiple the windows, right? Multiple sheets, and then you need to find the one specific one. And to assigning that one, you can use like these options. And either way, we can upload this data set, and then now you may complain about this, like only CSV and SLSX. No, and we can use like the other data format as well. So let's see. We know that like that there are statistical packages as SAS and Stata and what else, like the Minitab and SPSS and Systat. And so there are many different like statistical packages, and they use a specific data format, and we can import all different types of data format into our program using some packages. That is nothing but like a foreign packages. Foreign packages allows us to import pretty much all different types of data format into the R program. Right? So here's the example, and I again install the packages, install.packages function, and package name is foreign, and then load that packages using library function, library parentheses foreign, and then you can use function, and in the one function is read.spss, meaning that, hey, I want to upload SPSS data file in our program. And one other thing, the one different option is like the last portion here, to.data.frame equal T. This is the somewhat different from previous like a function read.csv and read.xlsx. SPSS. But those kind of options can be found in our program. And how we know what kind of options are available associated with that function. And you can always type like a question mark with the function name. Then you will have the help sessions. All right. So when I just described this, the input procedure, you complain about that. Oh, the first complaint is what is R and what is R? And how do we see the data set and what does output look like and those kind of a question, right? So let me spend some time with the R and R Studio. And R is, as you know, this is the free, the open source software, statistical packages, and this in R has the model languages as S. S is prior to R, but both S program and R program is based on C++ languages. And so the pretty much all packages is written in C, C++, or sometimes Java, and sometimes Fortran. But pretty much all other languages is compatible with an R program. So you don't need to worry about it the whether the what kind of language has been used in the writing the packages. And also you can use R program in any operating system, Windows, Mac, and Linux, and pretty much all. And so you can use this R program, but R program, I don't know, about 5 years ago, and I used the R program in my computer. But since I used R Studio, and I never opened the R program. Then what is R Studio? R Studio is nothing but let's start with the editor for the R program, but they develop many functions the managing the project and print out the output very the fancy the output. And so this R Studio is compatible with the R. So people the R user is only using the R Studio. But unfortunately, R Studio is not standalone statistical packages. R Studio still requires R program in your computer. So after installing R program, if you install the R Studio and you are ready to use the R program within the R Studio, okay? And again, R Studio is very good to the managing your project. And so, all right, well, the both are free. And so if you want to install the R Studio, just to go to the Google and R Studio, then it will pops up and you can download and install. And how does it look like? And this is the R Studio output. So they have 4 different the sections, and one in the left upper corner in here, and this section is for the syntax. So whenever you want to running some statistical analysis, you type the syntax in here, this section. And once you have a syntax in these sections, and you can running that syntax, and then output will print out at the bottom in here, left corner, the left bottom in here. And this one is called the console, but this console is exactly same as our program. So if you just open the R program, and you will have only this section. And R Studio provide more. And the top right corner, and this is for an environment and history. So whenever you generate, import, the creating the variable, all variable name, data, and will be listed in these sections. And history as well. So when you're running that. So this is pretty much same as like the journal file in SPSS. And right bottom in here, it has like many functions. And most, the our user using this section for like, the printing the graph. Uh, but it also provides like, the some detailed helps in this section. And sometimes like, the assigning the working directory, meaning that where your file is, well, your like your data file is, and those kind of, the file directory can also be, found in this section. So this section is like, the much more like in the informative sections. And so this is like, the R Studio. And R Studio, and what it looked like in, practically. And this is what it is. And here, I just, typed our syntax in here for this workshop. And when I'm running some analysis, and like in the left bottom is printing out like, the result. And then right upper corner and listed all variables, data, and corresponding informations. And right bottom in here, and this case, like, I looked for, the more information on t-test. So they just listed, how we conduct the t-test, what kind of function is needed, and what kind of like, the component will be listed in the analysis. And here, like, under the arguments, and they just, they're listing what kind of component you need to running, the t-test. So this is R Studio. So we've seen the like R and R Studio. And so I address your kind of complaint, like what is R and what is R Studio. And now when you have R and R Studio, and next step is like, what kind of basic functions can be done in R? And what kind of function requires like, the packages? And here in, the learning with the simple command, and I want to use, the most generic functions in R. And so we will see like, how these functions is like, the familiar with, or like, how they're named with the familiar like, the notations, right? So learning R with the command, and here first like, the help. And if you want to help, and you can always type like a question mark and, the some statistical terminologies. And in the cases like, I want to know how I can calculate the mean of, the vectors, or the, the numbers. And so I just, typed with the question and mean, and then they will print out in like an RStudio section how you can calculate the mean. If this mean is not a genetic, the functions, and something like, this mean requires some, the specific packages, you need to, that R Studio will provide more information, what kind of packages is needed, so that like, you can use this function. So don't worry about it, whether that will be in like, that will be the genetic function or not. And then when I typed in mean, and they just, describe how I can use these mean functions. And so I just, use the mean function in here. So in this case, mean is a genetic function. So if you have any kind of the vectors and number of, the array of numbers, and you can just calculate mean. And you may know the example one data set, right? We have 3 columns, x1 and x2 and x3. And x1 is like, the Dr. Cha explaining like this is like, what was that? Anxiety level of, the male and female. So this, we want to calculate the mean in here. So the mean parentheses the variable that will, print out the mean. And as you can see, like all, and the mean is 3.7 in here. And you may see that like, there are more options as like, the vector. And here I use the mean parentheses example 1 bracket comma 1. And whenever I use the bracket, and this bracket is associated with like the matrix format. So in this case, like example 1 has 3 columns, x1, x2, and x3, but it also have 10 data set, 10 rows. And so the before comma indicating rows, and after comma indicating column. If I just the empty in like the before comma, meaning that consider all rows. And if I specify the 1 after the comma, meaning that I just want to consider in the first column. So what it means is, hey, when I calculating the mean, I just want to considering first column, all rows, right? And in this case, mean value will be the same as before, right? So we could have like the mean function in here. And so, right, this is okay. And then what if I want to add additional variable? If I want additional variables, and you can type like additional variable, and you don't need to making new data set in Excel, and you can just add a variable in our program. So for example, like the example 1 $x4, meaning that hey, I want to have x4 variable. We don't have x4 in the data set. Don't worry about it. Just like $x4 and R will create like the first column, and then here C 1 through 10, and just considering, oh, this array of numbers will be the first column with variable name x4. So this is our, how R create the variable. This is this is good enough, right? It's easy. And here x5 is like another one, the C 10 through 1. So this is like the fifth column. The reason I just gave 2, and there's differences, and x4 with the less than minus sign, so the the left arrow, and but like the x5 is equality sign, right? Their functions are same. Their functions are same. So you can use the either notation in here. All right. Then we can add a variable with new like the data set. That's good. That is how we adding variable in the Excel file or SPSS file. And I just introduced like the indexing in here, and because this R program is still like a programming languages. And here's the example. And example 1 $x4 is greater than 7 and greater. And the computer stuff is just doing that like the binary coding, right? Either wrong and right. So this inequality means what what value is greater than 7 in x4, the variable. So x4 is 1 through 10. So 1 through 7, they will be less than or equal to 7, right? The all kind of force, right? So our print out force up to 7. But when we have like the 8, 9, and 10, that is like a true value because those are greater than 7, right? So this is kind of programming languages. And it will be like the following function is not very natural to you. For example, like sum example 1 at $x4 greater than 7. It looks like we want to add values whose are greater than 7, right? However, we just learned that inequality is just the programming languages. They just do like the either false or true, right? So this summation notation is collecting all true values, and we have 3 true values, right? When the value are greater than 7, the computer say the true. So here 8 and 9 and 10 are true. So true is 3. So the summing up the true values, and this is 3. So the output is 3. So function is very natural, is very familiar with us, and it looks like almost the same as what we did in the statistic, but sometimes it's not. And still, this is a programming languages, right? And now, then how we can, getting, the values greater than 7 and greater than 7, and you can use the bracket things in here. The bracket things is like indicating the matrix format. And here, example 1, $sign X4, this is, the first column. And now bracket things is we are looking for the values whose value is greater than 7. And here, greater than 7 is 8 and 9 and 10s in the rows, right? And in the cases like, they just save those, the column, the rows as another object in here, larger than 7 object. And so if you print out larger than 7, it will list it 8, 9, and 10. And here, I just introduced like a semicolon in here. Semicolon is just like the asking the R is running separately. So semicolon in the one rows, and R will running this one, and then R will running another one. Whenever we just type the data and vector and the matrices in our program, they will just print out data, matrices, and vectors. So this is like the one thing. So we've seen that like the basic things is very familiar with us, but still like the programming languages. But the programming languages is the big beneficiary in the R program. The reason is that like whenever we're dealing with like some structure of the data set, and it's very easy to dealing with that. So for example, like I want to save some list of like words and numbers or the characters, and I could do this one. New list equal to list. List function is save the new values in a variable name. So when I say the list, x6 is double quotation welcome, meaning that, hey, this guy want to save welcome in x6 variable. And here, x7 is equal to double quotation 2, and this guy want to save 2 in x7 variable, and so forth. So still like we can add like the other variable with numbers. X10 is double quotation 2017. And when you make this list, and here, when you just type is dot list function, is dot list, is this list? Is this a list? And then the answer is true. This is a list. He created a list using the list function. Okay, then what it is. And if you type the new list in here, and it will type like, hey, this guy create x6 to x10 variable, and each variable include this information. Welcome to syntax-based workshop, and 3 exclamation marks, and 2017. This is good. And when you have like the list in here, and new list bracket 2, and meaning that, hey, we will considering the new list, but second component, what is that? Second component was x7, and there was 2, right? And so they just print out 2. So we can get like the information in the list, right? This works for like a data set as well. And you may guess that like whenever we have those kind of component, and it's very easy to recall the component of the data set and the list. And that will be very useful whenever you're running like some simulation later on. And now I want to discuss, introduce a couple of more things. And one thing is related to like the matrix form. So most likely, the data will be saved in the matrix form, but you can type like in the matrix. And here, I just used like the matrix function in here, A equal to matrix. So I want to generate matrix and save in A, and matrix is example one $x4. I will use the the x4 variable, which is 1 through 10, right? 1 through 10. So the first one, this x1 $x4, just indicating there is some numbers, and we want to have like a matrix. Matrix is that consists of rows and columns, right? And you can define like the rows using n rows. N row equal to, meaning that hey, I have 10 numbers, but want to make 2 rows, then automatically column number is going to be 5, right? So the 2 by 5 matrices. So this is how we can generate matrix in here. And when you're creating the matrices, and one great thing is about like the adding the more columns, adding more rows is very easy using like the genetic function cbind and rbind. Cbind is like whenever you have additional columns and you can add those columns in the matrices. So the cbind and matrix and additional numbers, and then this number 11 and 12 will be added at the last the column. So this is cbind. And rbind is like adding the additional rows. So the rbinds like the B matrices and numbers is 13 through 16. They just add those numbers and below and here, the third row. So the cbind and rbind is the easy to manipulate with your data set. Okay. And I just like the showing the matrix form of example one data, and example one data has 3 columns, x1, x2, and x3, right? And I just like the adding those the variables as what cbind, x1 first column, and x2 in second column, and x3 is the third column. So this is matrix format. And here E matrices is like the another rbind and adding those variable as rows. So the first row is x1 variable, second row is x2 variable, third row is x3 variables, right? So we can generate the matrices. All right. One last thing is about like the function in the matrix algebra. I think this is the most difficult question to you. And let me just go back to the slide. I have D matrices and E matrices. And D matrix has 10 rows and 3 columns. And E matrices has 3 rows and 10 columns. Can we define matrix product between D and E? So D times E? This is a question. Oh, this is not the math class and linear algebra. It looks like a linear algebra class. And what? E should be transformed. And E has 3 rows and D has 3 columns, right? And if we want to define D times E, the matrix will be defined, meaning that the columns of first matrices is equal to rows of second matrices, then the matrix is defined. So what I did is like the D times E, and here, and resulting matrices is the remaining portion. So D has 10 rows, E has 10 columns, so the resulting matrix is a 10 by 10, the matrix in here. And the reason I just introduced this, and when you're doing the scalar product in the R program, and you can use the asterisk as before in any kind of calculator, But whenever you multiply the matrices and you use like the percent sign, percent asterisk percent is meaning that we are doing matrix operation, matrix product. Okay. And one last thing in here, like the matrix format and data frame is slightly different, and some function does not allow you to use matrix format as data set. Right? So whenever you have a matrix format, you do better like converting matrix to the data format. All right. Everybody cool? Okay. And then we can save this data set, and save is simpler than like the input or loading the data set. If you can use like the save data file, data frame, and you can save the data frame in R, and but in general, you'd better write this data set as .csv file so that you can like use this one in other like packages. So write .csv and file name, then you will have like the data.csv file in the folder, in the same folder. Okay, so this is data input and output, data input and output. And I know this is like the little heavy, and like it's not very the comfortable compared with SPSS, right? And but it is like the some benefit because we can use the programming languages. Oh, mm, okay. My computer is gone.
It's a lie.
Okay. What's a break?
You have to take a break. Um, but why don't you go ahead because it looks like we're live at this moment.
Okay.
So continue to do
Can you
share
bring?
screen,
Yeah.
share screen, and also we'll do
Mm-hmm.
this one.
Mm-hmm.
Get rid of this,
Mm-hmm.
this.
Full screen.
Yeah,
Okay.
I can navigate this
Okay. Thank you. Yeah. Uh, Let me continue, and like the and this one is gone. And
Can we move to the side? I don't know how to turn on this part.
oh, I see. No, I see. I don't think this is the problem with the computer, and this is a problem with this system, like around 5:30 and this. Yeah.
Oh, to start to close down everything.
Yeah, sometimes. Okay.
Oh, automatically close? Okay.
Yeah, most likely. Okay, and I think you can watch that slide, and
Well, if you want to move, then why don't you move to the next slide? You have a better one.
if you have like, all right. Mhm. Okay, let me continue. Chapter 2. We're kind of going to break a couple of minutes, right? uh, Now, data management, like I don't want to spend a whole lot of time for like the data management in here, but like I want to discuss some important stuff and the most used in my analysis, and so that may be like very helpful for you guys. And here, data management, section 1, structure and metadata. And one complaint about like the R use from the R user, and hey, SPSS we have like a data view and a variable view, and the variable view specifically like the easy to labeling the variable, so help us to dealing with the variables. But we could do the variable view in our program using the function of command and attribute. And here the command function, and this is like you can add any label for the variable, and as well as like the data set. So for example, data f $x1, hey, I want to labeling this variable with the first column in the data, in the data f, then it will save labeling in this data set. So if you want to use the attribute function, attributes data f $x1 command, and it will print out this label is first column in the data set. And it works for the data file as well. And when you have data file, and you can using the function attribute parentheses data f, and it will list it all information about the data set, the variable names and row names, and comment in here, and class. So we just added like the comment for this data set, as this is a toy data set. So sometimes this is very useful, and whenever you want to save like labeling for the variable or the data set, right? And now I would like to introduce 3 functions for like the descriptive statistic and generating the categorical variable. And summary function, this is a generic function in our program. And if you just like type the summary parentheses with variables or data set, and it will print out like a basic descriptive statistic, including mean, max, and quartiles and mean value. And if there, if the variable has missing value, and it will also list it how many missing values in there. So it's very informative. But this summary functions can be used in some other packages. And if the summary is used with other packages, other functions, and it will just print out all information that object has. So this is very the useful information, and we will discuss this one in the later. But I would like to introduce cut function and factor function. Cut function is whenever you want to generating the category from the continuous variable, and you can use these cut functions. And cut function is that like hey, the cut function can generate the category, and you need to add variable name first, and need to provide like the cut points for the category, and then labels option is like for creating like the labels for each category, and Then right is first option is that we do not include like the lightest like values. And so using these call functions, you can generate like the category. But once you generate the category, and R is really computer like the packages, and it does not recognize this is a category, and it just recognize some the character. And if you want to this category in the analysis, you need to changing the format as a factor. So the factor function is allowing the categorical variable as real categorical variable in the data set. So something like the data f dollar sign new category one variable is factor parentheses data f dollar sign new category one, and this is like the factoring the variable. So then it can be used as a grouping variable in the analysis. For example, like the analysis of variances. Right. So this function, but the most important thing in the data management is like how we can merge and like the combining and subsetting the data set, right, in the R program. And I want to introduce like the two functions for selecting the subset. One is a filter, and the other is subset. Filter is commonly used to select data set corresponding to categorical variable. So for example, we just generated like a categorical variable, and data F include categorical variable, which is new category one. I would like to select all data whose new category one value is equal to one. Then this filter is like just filtering those data set and dropping all other variable. So the new category one is equal to 2, 3, and 4 that will be dropped. So basically, this filter will keep the number of columns. The columns is the variable, right? But it will drop in many rows because like it will select a specific category, right? So filter is okay. And but like whenever we're dealing with the subset, we often use like a subset function instead of a filter. The reason is that subset has the same function as in filter, but also it has the extended function like that we can select a number of columns as well. So for example, here, if I use like the select data f comma x1 and x2, this is nothing but, hey, I want to select x1 column and x2 column from data f. Then data f1, 2 is nothing but like x1 and x2 data set. And it does not like dropping any rows, but it does drop like the third data set in here, And subset function can also work for like the selecting the specific categorical value, the new category one equal to 3, and if you use like a subset data and condition, and it will save the specific the values corresponding to that category. So it's same as like a filter function, right? So this is like the same function. So we use the subset function a lot. And the last one in the data management, and in many cases I used like the some specific melt function and decast function. What are those? And those are like the functions converting data from wide to long format, or like a long format to the wide format. And if you're working with like the longitudinal data or the repeated data set, and you need to like the reformatting. So if you have like an all variable listed in the columns, and you need to stack those columns as like a long format. And in some cases, like you need to like the restructure the stacked data set into wider format, and you have to the converting that. And melt function in the reshape two packages, and this is converting wide format data to long format data. Wide format data to the long format data. So here, basically like I had data F56. Data F56 is like the has x5 variable and x6 variable, and whose value was like the listed under the measurement in here. And this is like the long format already, but I just want to explaining like how the wide format looked like. And wide format has like an x5 variable and x6 variable, and we stack this x5 and x6 variable in the long format in here. Long format in here. And melt function has several options, and you have to be very careful to setting up like the options. And pretty much all like the genetic function as the in the data management start with the data set and data F56, and next id.values. id.values, this is like identifying what kind of variable is like a constant value. And here we have ID and sex variable, those are constant. And next, measure.values, this is what kind of variable in wide format will be stacked. So we can list like the variables and x5 and x6. And third one, variable.name. If you want to stack x5 and x6 in the long format, you will lose those variable name. If you want to naming this new variable, what it would be. And so I just typed the condition, double quotation mark and condition. And last one is value.name. So if you want to stack those data set and what kind of variable name you will use for that values. So I used in the measurement. So this melt function allows you to converting wide format data to the long format data. When you stack this data set, and you will see these cases. Condition will have like the two different variable name in the wide format, and measurement will have all stacked data set in here. Okay? And dcast function in the reshape two packages, and this is converting long format to the wide format. And this is like in the simpler than melt. And as you can see at the bottom and here, dcast function and data F56 long, and this is the long format data set. And if you want to keep the constant values, and you can list those constant variable and left hand side and here, left hand side of a tilde. So the ID plus sex, and this is nothing but like hey, I want to keep the ID and sex variable as constant value, but here condition is I want to converting the long format to the wide format. And so here condition will have like two different variable name, and it will be separated in the long format, the wide format. And comma value dot val equal to measurement. This is nothing but hey, those values were stacked. So I just want to separate these values under the new the variable x5 and x6. So this is you can have the wide format. When you do the wide format, and you will have like the here data F56 wide. It has ID, sex variable, x5 and x6. And a couple more things about like the for the data management. And one thing is arrange. And we often sorting the values, right? And the descending, ascending order, and sorting the values. You can use the function arrange, and so arrange function. And here, if you want to, the sorting the data set in terms of sex and ID, and they can do that. Like you list the data file in here, and following variable name is the order of sorting. So the sex and ID, first they will reordering under the sex, and sex is the coded and 0 and 1, so the 5 zeros and 5 ones. But the 5 zeros and 5 ones within each category, they have like a different ID, and then second ID allows us to the reordering in terms of ID within each the sex variable, and we can list it ID. So 6, 7, 8, 9, 10, and here in 0, and 1, 2, 3, 4, 5 in like the one category. So we can have this sorting variable, right? Sorting variable. And the reason I just introduced this sorting, because like when you merging data set in SPSS, they ask to sort the ID variable, right? And and so that's kind of the bothering me in SPSS. But in our program, we don't need to do that actually. If we want to merging this data set, as long as the ID is unique, and you don't need to the reordering or sorting that ID. So for example, here data f sex, and here ID and sex variable in here. Now my ID is listed 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, because we sorted like according to the sex and here, right? And I want to merging this data set into original data, data F. It does not have sex variable. And in the cases, you can use the merge variable and merge parentheses. You have to list two data set that you want to merge. So one is data F and the other is data F sex. And if you want to merge, and you need to have unique ID variable, which is like followed by equal double quotation ID, then all is true, and ID is like our unique ID. Then this data set will be listed in here. So although your data F sex does not have ascending order in ID variable, it automatically the reordered in the new data set. So you don't need to worry about sorting the data set. Okay. All right. So this is like the data management. And can you have like a couple of minutes break, and then I will finish up the remaining sections about the 20 or 30 minutes. Okay. All right. Can I just start? Oh, okay. All right. I will say like there's some basic statistical function, and so in this case like when I when I'm preparing this workshop, and I have there's something in my mind. Which one is like what is the best like in the uses with our program, and I would like to say that some type of simulation study is kind of the core thing, or like the some best functioning in our program. So in this case, like the instead of listing all different statistical function in here, I just introduced the several functions, and it might be used in like the simulation studies. All right. So here, probability distributions and random number generation and random number generation. This is really easy. And so like the if I want to generate some numbers from the uniform distribution is nothing but every value within the certain range has the same probability, of being selected, right? So our unit F, so RUNIF, which is nothing but random number generation from uniform distribution. And in the cases, you have to know that what kind of options we have to add. So our uniform required how many values you want to generate, and the variable in uniform distribution is minimum and maximum. So you need to assigning minimum value and the maximum value. So this is nothing but we want to have 10 values from uniform distribution from 0 and 1. Easy, right? And then they will list it like 10 values in here. And another function is rnorm, RNORM. This is nothing but random number generation from normal distribution. Normal distribution. Yes. U, oh, UD, and this is like it's just the name of the vector that we generated, and I used like the what is the uniform distribution, but like this is meaningless, as any variable name can be used, and UND is another like the vector of values generated by normal distribution, mean zero and standard deviation 1, and 20 values, right? So we have the 20 values in here. So this is so simple, right? And if you want to generate like the values from the normal distribution has two variables. One is mean, and the other is standard deviation. So you can assign those values in this function. That's it, with like how many numbers you want to generate. And Now, I want to introduce like another one. Oh, okay. No, no problem. Mhm. UD second line, and this UD here, and this one is like the I want to generate the value from the uniform distribution and save those values in UD. Right. And so when I do the UD in here, the R is printing what kind of value is saved in this UD object. Is it clear? All right. Good, good. And this is like the normal distribution. And here is like the function M, B, R, and ORM. This function is random number generation from multivariate normal distribution. But this function requires mass packages, MASS packages, right? But think about like in a multivariate normal distribution. In multivariate normal distribution, our mean is not a single value. Mean will be vector. And also, our like the variance is not like the one value. Vector will be variance covariance matrices, right? And so we have to assigning those conditions. And here, I just used mean as like the value. REP is function generating the vector of zeros with 10 numbers. So we have 10 zeros in here. So this is REP. This is repeat values, repeat zeros 10 times. So I saved that the zeros as mean, mu in here. And sigma, I just set it up like 10 different means. Then variance covariance matrices should be 10 by 10 variance covariance matrices, right? And I'm lazy boy, and I just want to use these variance covariance matrices from like what we have and in the data set, like the data full, and it includes like the 10, the more than 10 columns and 10 rows. I just selected like the 10 columns in here, and then every like the row will be included. Then it will be like a 10 by 10 matrices. I just selected these matrices, and you can select any matrices in here. Okay.
Every row you selected a column and second to 11 columns.
Yes, because the variance covariance matrix should be 10 by 10 matrices, right? And the full data set include 10 rows. We already have 10 rows. And to make the 10 by 10 matrices, we have to select the 10 columns. I select 10 columns from second column through the 11th column. So when I use this in the mu and sigma, I can generate like the multivariate normal values, and I selected 5, which is like the 5 different vectors, not numbers, vectors. And mu is 10 zeros, and sigma is like this 10 by 10 matrices, and then it will generate like the big data, and which it has like 5 different rows, because we ask generate 5 different values from this multivariate normal distribution, and but it has how many columns? And it will have 10 columns, right? So each row has 10 columns. So we can have like we can generate this data set. All right.
So you cut the first 4 out of the 10. Right?
Yes. I'm sorry, because like this this is a big representation. All right. Now, next, in like a slide, I want to show that plotting this probability distribution as one example. And first, like I would like to make these distributions in our program. It does look like we have two different curves, and I consider like the solid line curve as normal distribution, and dashed line from the t distribution. And I would like to create these plots. And so what I need is I have to have like x values, and y values will be like the generated from the normal distribution and t distribution. But x values is just like the sequence of the values, and I select x values from -4 to 4, and with like the 100 points. So actually we have the distance as 8 between -4 and 4, and then divided by 100. So we have the 100 data point. What we want to do that is here I use the norm function. The norm function is assigning probability of normal distribution corresponding to the x values. Again, x values is selected as like the 100 points between -4 and 4, and we just calculate like the probability corresponding to x, and then considering this probability value and save those values under und.x, and this is in the corresponding y value in the normal distribution. And second one, and I also generated like the probability of from the t distribution corresponding to x values. And so dt function is assigning probability corresponding to x values. Again, x values is 100 points between -4 and 4, and dt is like assigning the probability, but we do need degrees of freedom for the t distribution, right? And I assigning degree of freedom for t distribution as 1 in here. Then t dot value is nothing but the probability of t distribution corresponding to x value. And what I'm going to do, I'm just plotting this, the und.x and t values with x variable. And plotting in here, plot function allows us to plot these two curves, and here plot x comma und. Plot means your x-axis variable, y-axis variable in the order. So I use x as x variable and und.x as y variable. Again, und.x is probability corresponding to x values. And now type is n. This is like a strategic, the things. Type is n is a don't produce anything, and but just the y lab is equal to f of x, and y-axis has name as f of x. And so first the plot line, actually it does not include anything, but this x-axis and y-axis and name of y-axis, f of x. Then how we can get into these curves? And we can add those curves using the lines function. Lines function is only works after plot function. When you set the plot, and you can add lines using lines function. Here, first lines function, x comma und.x, which is I want to plot x comma und.x, which is a normal curve, right? Third line, lines parenthesis x comma t values. I want to plot these t values in the plot. So the dashed line. So up to third line, what we have is we have a normal curve as a solid curve, and we have a t distribution for the dashed line. And we have those lines, right? But if we have only solid line and dashed line, and we will be confused with what is normal distribution and what is t distribution, right? So we could add like the legend in here. Legend is nothing but like some keynote in the figures. And legend, top left, I want to add the legend and top left part in here. And first, line type is 1 and 2. I use the solid line 1 and dashed line 2. So solid line 1 and dashed line 2. And then here, bty equal to n, and most likely in options, n meaning the nothing. And this bty is a boundary line. I don't want to use the boundary line for the legend in here. But I would like to add explanation of this, the two line type 1 and line type 2. And line type 1 is like the normal distribution, mu is equal to 0, sigma is equal to 1. So here, expression function is using some the Greek notation, and the normal distribution mu is equal to 0 and sigma is equal to 1. And so expression function is like something defensive functions and can be used like a Greek notation in the figures. And past, and here is we just passed some words in the legend, and here t with degrees of freedom df dot value is 1 and dot the degrees of freedom. So this legend is just adding some explanation about like your curves. And this is a little fancy, but like if you can type question mark legend, and then our program will produce all kind of the detailed options about it. All right. And the reason I'm just to introduce this one because when I published the papers, and they asked me to use like a Greek notation in the figures instead of like just the M or SD. They just want to use like the mu and Greek the sigma as those. And so I need to I needed to find these kind of options. But anyway, and summary statistic here. The summary statistic mean we've seen before, right? I added one more like the mean type of summary statistic, which is a weighted mean. Weighted mean, WTD dot mean. In the package HMISC packages, and you have like a weighted mean. So if you want to calculate the mean with some weights, and if you're working with like a large scale data set, like in teams and like a PERS data set, they have the weight, right? And in the cases like you can calculate weighted mean with this function. But using this weighted mean is pretty easy, and just list your kind of the variable you want to find the weighted mean. And second, the component is about weights. So variable name and weights. Then it will calculate the weighted mean. So the raw mean was 24 for x1, but weighted mean was 25.25. Right? So it's kind of the useful information, but as we know that like the descriptive statistic is often used to showing the distribution of the variable. And when we discuss about the distribution of a variable, and not only mean and standard the variances, but also skewness and kurtosis, those are important the values for showing the normal distribution. And kurtosis and skewnesses, and you can use the function the packages moments packages. There are lots of packages in here, right? But like not very difficult. So for example, like if you just type question mark skewnesses in our program, and they will tell you, oh, you want to find the skewnesses, then why don't you use like in the moments packages, and they will give some direction, right? And so skewnesses and kurtosis in the can be, these functions can be used to get these values, but requires the moments packages. And sometimes you need to find like the standardized the score in your data set, right? And for example, like in the math and reading score, and you want to compare those things, and you need to standardize those scores. And in our program, you can use function scale. Scale is nothing but like normalizing a variable. So basically, like the variable minus mean of variable divided by standard deviation. This is the how the scale function that does. And some of the statistics, like the as Dr. Cho explained the correlation and like in some kind of the crosstab, and this is very useful. And the R can be they can calculate the correlation, and even like the interrate reliabilities, kappa 2, and kappa values can be calculated in the R program. Good thing is the COR correlation function is a generic function. You can just type in the COR and parentheses and the variables you want to find the correlations. And it also allows you to calculate the Pearson correlation, Kender's tau, and the Spearman's rho can also be calculated using this the COR functions. Interrater reliability, and unfortunately, this also requires the packages, which is called IRR packages. And in the cases the kappa 2 parentheses variables, two variables, allows you to calculate the kappa values and interrater reliability. And but like here, interrater reliability is something odd, like a negative 0.04, which is like the disagreement and opposite the agreement. And but this is based on like the kind of a toy data set. So but if you have like the rater like ordinary variable, and you will have like the high values. Okay, so this is basic functions. And again like this is not like the full list of the functions, and some specific functions that I mostly used in the simulation study. So if you plan to running any kind of simulation studies, and this will be helpful. And other things can be found in like the R program, or like the Google format, right? And last section is about the statistical modules, and the Dr. Cha explained like a graph, descriptive, correlation, crosstab, and t-test. And I'm not gonna explain any detail about the statistic. He explained very well, and I don't need to do that, right? But I'll try to generate the same things. I try to running the same analysis, and in using the R program. So first, like a graph, and he generate the bar plot, and this is nothing. Bar plot was nothing but like anxiety level for like the two groups, right? And x1 was the x1 was anxiety level, and x2 is grouping variable. He calculate what? He calculate sum of like this x1 values grouped by x2, right? And so we can calculate this the sum values, and some values I use the packages, which is like the DOBY packages. Sorry, but like the R is case sensitive. DOBY B is like a capital letter B and Y packages. And in the cases like, if you install this DOBY packages, and you can use, the function summary by, and summary by allows you to calculate the sum corresponding to the grouping variable. So here, summary by x1 tilde x2, I want to getting some summary value of x1 grouped by x2. And what kind of summary statistic? I want to have like in the sum. So fun is equal to C parenthesis sum, and it will produce some values. So the output looks like x2, 0, and 1, two category, and you have like the 17 for category 0 and 20 for category 1. When you have this data set, and easy to plot like in the bar plot, and the function is bar plot. And if you want to plotting the pi, and it's similar as like the SPSS and bar plot. And what you can do that is bar plot, and then like the data set, and we have like the 2 0 and 1 from x2, and sum corresponding to the 0 and 1. And here, this is a basic bar plot in here. This is basic bar plot. But it feels like that there was a couple of the component that was missing in here, right? X-axis is just the nothing in here, and the bars is not distinguishable, and which one is which. And those kind of things can be added as options in here. And I just replicate his bar plot, and with tighter score in classes, and x-axis is in 0 and 1, and x2 in here. I just listed all options at the bottom in here. And if you want to see a little more options about the bar plot, just a question mark and bar plot, and gives you like the help session. All right. And now here we have a pi function, the pi plot, and using the pi function and pi function, and pi function, for me, I would like to be that this pi chart is very informative or self-explanatory, and so I would like to add some level. Hey, I will have a pi plot for x1, but want to add some description, which is using the labels options. And one is the sum score for the male and sum score for the female. And here, when I the plotting the pie chart in here, if I do not using those options, and you will have 2 different sections in here. But if you add like labels option and main title options, and you will have like this output. Does it make sense? And I'm not going to dig into all the options in here, but you can again type like the question mark and pi. Right. Histogram, we use like a histo function, HIST, histo function. Histogram, example 1, x1, and color is orange, and we'll have the histogram in here. But when we have histogram, as we've seen in the SPSS, it's very informative if we add normal curve, right? And so in our program, normal curve can be added in here, but it needs some some work and to do that. And I just want to leave in here as a syntax, and if we have time, like we will take a look at it. But the R is able to do pretty much all things in SPSS, but as you've seen that like there are many different options in here. But in my experience, if you use the R or La, these options is not that kind of a difficult one. It's very like in the natural. So whenever you need this one, and you just type the question mark and the function, and they will direct you how to use those options. And scatter plot, and we've seen that like in the plot function, and plot function required x variable first, y variable second. And if you use the plot x3 and x1, and you will have like this scatter plot. We will have a very simple scatter plot, but this plot can be used in like in the regression. And the SPSS function, like whenever we find the scatter plot, and some kind of an option allows us to have like a regression line, and also like the lowest curve. And this can be done in the all program and here. Right. The next session we will discuss about the regression analysis, and I will dig into it about like this scatter plot. And descriptive statistic. Here I reviewed the summary and quantile function. Quantile function is like you can get the percentiles. Quantile function allows you to calculate the percentiles, and percentiles can be like manipulated with the probs option, PROBS, probability option. Not only quartiles, but also any percentiles can be set it up in here, so you can find like exact like the percentiles values using this quantile. And most commonly in the social science, and I don't know, many people use the psych packages, and psych packages like is very useful when you doing some descriptive statistics, especially like when you have grouping variable. So especially like the describe by function allows you to calculate all descriptive statistics the described grouped by grouping variable, categorical variables. So here, I just showing this one. When we have example one data set, x1 was continuous and x2 was like the categorical variable. So if you use the describe by x1 and the x2, they will describe like all values in here. Mean, median, standard deviation, and all different statistics in here. Okay? All right. So the correlations, as we've seen in the correlation, COR function, right? And I'm not going to discuss any more in here. Crosstab. And he emphasized, like Dr. Choi emphasized, the crosstab is very useful. And here, like, I just want to showing that we can have a crosstab, and even for like in the higher dimension. 2-dimension is definitely like the matrix format, and 3-dimension is like the usually we have additional kind of the column portion in here, x1, and here x3, and here x2. X2 has only 2 categories, so it's kind of the stacking like in the 0 and 1. And 3-way table is needed whenever you test mutual independence. So chi-square test can be done by like the summary statistic with the 3-way table. 3-way table was done like the F table functions with X tab, but when you find F test values, and summary function is just conducting the test, mutual independent test. And we've seen that this summary function as descriptive statistic, right? And now we have like the summary function as running the test. All right. And another crosstab is like I just showing crosstab function in the G models. And if you're running like a crosstab in SPSS, you've seen this kind of the big tables, and can also be printed out in our program. And so I just listed in here. But more important thing is like a crosstab could include like a chi-square test. Chi-square test, and we can just like use chi-square dot test with the two variable. It will learning like in the Pearson chi-square and with the p-values. But if you want to use some kind of the simulated p-values, so for example, your sample is like a little smaller, like a 20, and then you can use like the simulated p-values, and this is like the simulation based on chi-square, and based on like their correlation, they just simulate the data set and showing that how likely this correlation can be understood. And the reason I like this kind of a chi-square with the simulated p-values, and their result is fairly similar as like the Fisher's exact test and some other like a non-parametric test, meaning that simulated p-value or chi-square is somewhat like free from the strict assumption in the chi-square the test. And let me just like this is I explaining like the inter-rater reliability before, and so I want to just go over three the t-test, okay? And this is almost done. I like I can just spend 5 minutes for doing this. One sample t-test and independent sample t-test, paired sample t-test, all can be done with the function t.test. T.test. T.test, and if you want to doing one sample t-test, you need hypothesized mean value, right? So in one sample t-test, you can do t.test parentheses variable you want to test, comma, mu is equal to 5. Mu is equal to 5 is hypothesized value, right? And first component, example 1, $x1 is the one sample, the variable. And this is like the one sample t-test, and you can get like a 95% confidence interval. If you want to have a 90% confidence interval, you can add the one options, confidence interval dot level equal to 0.90. If you want to running, I'll just skip this one. If you want to running independent sample t-test, and you need two variable, right? You need two variable. Do you need two variables? Yes, one is for data set, and the other is like the grouping variable. And in our case, like x1 is continuous variable, x2 is grouping variable. So we can conduct independent sample t-test. So comparing the males and females. And one last thing is about paired sample t-test. Paired sample t-test, we need two variable, but those are paired, right? In our case, the variable x1 and x3, in example 1 data set, we can consider those are paired and then running the analysis. And they're only required last the option, paired equal to true. So list the two variable and paired equal to true option allows you to running the paired sample t-test, right? I'm not going to explain about like the result, because this result is exactly the same as the SPSS result. Okay? Any questions? No questions? Crystal clear? I don't think that R, this is intersection, like please take a look at this slide and the joining the next section, and the next section is about like the general linear model and simulation, the stuff. And so you may see the beauty of, the R program, right? Okay, if there's no question, I want to stop here. Thank you very much, and please join like in the next intermediate session again. Thank you. I should have finished a little earlier because well, I think this is